get ready because we're going deep on these titans today. You sent over, well, some really interesting pieces from this paper. Titans, learning to memorize at test time.
Right.
It's a kitschy title. And plus your own notes on like how they use memory.
Yeah.
And why titans might actually be better than transformers, especially on those, the giant data sets.
Yeah, yeah. It's really interesting how these models can handle so much information.
Yeah. So I guess our mission is to kind of unpack what makes these titans tick and why everyone's saying they might totally change how we process like all kinds of data.
Definitely.
Where do we even begin with something like this?
Well, I guess we can start with, you know how a lot of AI models really struggle with super long sequences of data?
Yeah.
It's like imagine trying to remember a grocery list that's like pages and pages long.
Oh, wow. Yeah.
Our brains just like, they can't hold it all. And neither can most computers.
Right. Yeah. I mean, you think about like RNNs, they try to just cram everything into this tiny space.
Exactly.
Like trying to fit that huge grocery list you're talking about onto like a little sticky note.
Yeah, and even transformers, which are usually pretty good with longer sequences, they even have this like scaling problem. The more data you feed them, the more expensive it gets to actually run them computationally.
Oh, so the longer that grocery list gets, the harder the transformer has to work.
Right.
And eventually it just gives up. It's like they hit a wall.
It's like they just can't keep up. And that's why this whole Titans research is so fascinating. They seem to have like figured out a way to deal with these massive amounts of information without totally, falling apart.
So Titans to the rescue, right?
Yeah.
Like the cavalry's arrived with this totally new approach.
Exactly. And the really cool part is that they're taking inspiration from how the human brain works, using short-term and long-term memory. So instead of just treating every single piece of data as like equally important, they've come up with a way to actually prioritize and remember what's really important.
That's amazing. So it's like almost human-like in a way. So tell me a bit more about this two-part memory system. How does that even work?
Well, think about it this way. Like, imagine you're learning a new language.
Okay, yeah.
The words that you actually remember are usually the ones that kind of surprise you.
The ones that stand out, yeah.
Right. Like maybe they sound funny or they're totally unexpected.
Yeah, yeah.
So Titans actually use the same concept. They call it a surprise metric.
So instead of trying to remember absolutely everything, they just focus on the stuff that's really unusual or different.
Exactly. It's all about figuring out which information is the most important, even within a massive data set.
I mean, this whole idea that the model is actually learning to memorize, that's just wild to me. Isn't memorization usually like a bad thing in machine learning?
Well, you're right. In the traditional sense, yeah, like it can lead to overfitting.
Yeah.
But with Titans, it's different. It's not just blindly storing everything. It's much more controlled and strategic. And it's all guided by this surprise thing we were talking about.
Oh, okay. So it's not just memorizing for the sake of memorizing. It's about actually like recognizing what's important to remember. That makes a lot more sense.
Exactly. And then there's this other thing, like what happens when the memory starts getting full, right?
Yeah, to just keep adding more and more stuff.
Well, that's where this forgetting mechanism comes in. So Titans can actually selectively forget less important information as time goes on.
They clearing.
It's like clearing out your mental closet to make room for, new experiences.
So it's not just remembering. It's also about strategically forgetting. That's just crazy to me.
It is, yeah. It's a totally different way of thinking about AI. And this adaptive forgetting, it's really important. It helps prevent the model from getting bogged down by all these little details that don't really matter in the grand scheme of things.
Now, you mentioned that there are actually different ways that Titans can use this long-term memory.
Right.
The paper talked about MAG, MAG, and ML.
Yeah.
Can you break those down a little bit for us?
Sure. Think of them as like different recipes for blending short-term and long-term memory.
Okay.
So memory as a context, which is MAC, that one uses retrieved long-term memories to give extra information to the attention mechanism.
So it's like adding more context to what you're focusing on right now.
Exactly. Like imagine having these pop-up reminders on your grocery list. They're helping you remember things you might have forgotten.
Oh, I like that. Okay, that makes sense. What about memory as a gate or MAG?
So with MAG, it takes the information pulled from long-term memory and combines it with the stuff from short-term memory. But there's this like gatekeeper that decides which pieces of information are actually important enough to keep going.
Oh, so it's like filtering out the noise.
Yeah, exactly. Like a bouncer at the door of your brain, deciding what thoughts are allowed in.
I love that analogy. And then there's ML, right?
Yeah, memory as a layer. With that one, the long-term memory acts like a pre-processing step. So it's analyzing the information before it even gets to the attention mechanism.
Oh, so it's like having an assistant who reads your emails first and highlights the important parts, so you don't have to read the whole thing.
Yeah, something like that. So basically, each of these Titan versions has its own way of using long-term memory. It'll be really interesting to see how they perform with different tasks.
Yeah, that's fascinating. But, I mean, do they actually work? Do Titans really do better than Transformers in the real world?
Well, the results are pretty impressive, especially for tasks with really long sequences, like those needle-in-a-haystack problems where you have to find a specific piece of information in this huge pile of data.
Right, right.
In those situations, Titans consistently do better than Transformers.
So they're like super efficient researchers who can go through mountains of data and find exactly what they need.
Exactly. And it's not just about finding things. They also show a big improvement in tasks that require reasoning over long contexts, like understanding the plot of a book or following a complicated scientific argument.
That's amazing. So it sounds like they could totally change things in fields that need to handle these long sequences of information.
Yeah.
But are they limited to, like, language tasks?
Well, that's what's really exciting. The researchers have already shown that Titans can be used for other things, like DNA modeling and time series forecasting.
Wow.
It seems like they could be applied to a whole bunch of different problems.
They really are Titans then, huh? I mean, this is all super impressive. But I have to ask, are there any downsides? Can't all be perfect, right?
Well, there's always a trade-off. One thing to keep in mind is that the depth of the long-term memory can affect performance. A deeper memory usually leads to better results, but it also needs more computational power during training.
It's kind of like having a bigger library. It can hold more books, but it also
Yeah.
takes more effort to build and maintain.
Exactly. It's always a balancing act. You want the model to be as good as possible, but you also have to consider how much it costs to train it.
This has been a really, really interesting deep dive so far. I feel like I'm starting to understand just how powerful these Titans could be.
Yeah, they're definitely a game changer. I think they represent a huge leap forward in how we can process and understand information.
And we've only just scratched the surface. In part 2, we're going to get even deeper into how these models actually work. It's going to be fascinating to really see what's going on under the hood. Okay, so welcome back to our deep dive on these Titans. In part 1, we talked about like how they're changing AI with this whole new way of handling memory. But now I'm kind of curious to like peek under the hood and see how these things actually, work.
Yeah, that's a good place to start. Remember how we were talking about Titans having both short-term and long-term memory?
Yeah, like a tag team for processing information, right?
Right. So the short-term memory, it works a lot like the attention mechanisms in Transformers. It focuses on a certain window of the input, like a specific section of that data, and tries to understand how those pieces are connected.
Oh, okay. So it's like honing in on a specific part of that giant grocery list.
Exactly. But the thing is, short-term memory has its limits. And that's where long-term memory steps in. That's where things get really interesting.
Right. With that whole surprise metric thing, I'm still wrapping my head around how, like, a model can be surprised. It sounds so human.
Yeah, it's a good way to think about it. It's essentially trained to look for information that doesn't really fit with what it already knows. Like if you're reading a book and suddenly a character does something that you totally didn't expect, that's going to stick in your memory, right?
Oh, yeah, totally. So the model is constantly analyzing the data and picking out the parts that stand out, the ones that are unusual.
Yeah,
And those are the things that go into the long-term memory.
exactly. It's all about remembering things strategically.
Okay, that makes sense. But how does it actually find that information in long-term memory when it needs it? Is it like searching through a huge database or something?
Well, it's actually a pretty efficient process. So when the model gets a new piece of data, it creates this query based on that input. And it uses that query to look through the long-term memory.
Oh, so it's kind of like using a keyword to find a specific book in a library.
That's a great analogy. And the cool thing is that it doesn't actually change the long-term memory when it does this. It's like a read-only database.
Okay, so it's pulling out the relevant information based on the current input, but the memory itself stays the same. That's pretty clever.
Yeah. And then how that information gets used depends on which type of Titan architecture we're talking about. Remember MACE, MEG, and ML?
Oh, yeah. The 3 different ways of integrating the memory. It's all coming back to me now. Maybe we can just do a quick recap of those just to make sure everyone's on the same page.
Sure, no problem. Let's start with MAC, which stands for Memory as a Context. In this one, the information from long-term memory is used to give more context to the attention mechanism. So it's basically adding more information to what you're currently focusing on.
Like having a pop-up note on your grocery list reminding you of something you might have forgotten.
Exactly. Then there's MAG, or memory as a gate. And with this one, the information from long-term memory gets combined with the output from short-term memory. But there's this gatekeeper that decides which pieces of information are important enough to actually be used.
So it's like filtering out all the noise, making sure only the important stuff gets through.
Exactly. It's like that bouncer at the club, deciding what thoughts are allowed in.
Yeah. I love these analogies. Okay, so what about MAL?
So MEL, or memory as a layer, acts as a kind of pre-processing step. So it's analyzing the information before it even reaches the attention mechanism.
Oh, so it's like having someone pre-read all your emails and highlight the important parts before you even open them.
Yeah, you could think of it that way. So each version of Titans uses long-term memory in a slightly different way. And it's fascinating to see how those different approaches play out in practice.
It really is. I mean, it's amazing how these models are starting to do things that are so similar to how humans think, like with the surprise and the forgetting. It makes you wonder, are we getting closer to actually creating AI that's truly like us?
Well, it's definitely a step in that direction. The researchers who created Titans, they were definitely inspired by biological systems. And I think that's what makes this work so exciting.
It's not just about making algorithms that are smarter, it's about understanding how intelligence works at a fundamental level.
Exactly. I think Titans represent a big shift in AI. We're moving towards systems that don't just process information, they actually try to understand it. They can make connections, draw conclusions, and even adapt to new situations.
Okay, I'm blown away. I think I need a minute to process all this. But when we come back, I really want to talk about what this means for the real world. Like, where do we go from here? What's next for these Titans? Okay, we're back for the last part of our deep dive into the world of Titans. And we've covered so much already, like their, surprising memory tricks and the nuts and bolts of how they process information.
It's been quite a journey, really pushing the limits of what AI can do.
Yeah, for sure. But now I'm kind of thinking about the big picture, What is this, the rise of Titans, what does it actually mean for, like, the future?
Well, first up, I think we're going to see Titans being used for way more things. We've already talked about language processing and DNA modeling and time series forecasting. But that's just the beginning, really.
So, like, imagine Titans helping scientists make sense of huge data sets for climate modeling, or even, like, predicting earthquakes.
Exactly. Being able to handle these long sequences and make connections across all that data, it could be huge for scientific discoveries.
And what about everyday life, Could Titans change how we interact with technology in general?
Oh, absolutely. I mean, imagine AI assistants that can actually remember your past conversations, and actually build on them. They could learn your preferences, anticipate your needs, and become like truly personalized companions.
That's both exciting and, like, a little bit unnerving, right? It makes you think about all these issues with privacy and control.
You're right. It's super important that we develop these technologies responsibly and really think through the ethical implications.
Yeah, like, how do we even make sure that Titans are being used for good and not for something, well, malicious?
That's the big question, isn't it? I mean, like any powerful tech, there's always the potential for misuse. So we really need to come up with some clear guidelines and regulations to prevent Titans from being used for harmful things.
It's almost like setting up safety protocols for a new source of energy. We need to be sure it's being used to power the world, not destroy it.
Great analogy. And it's not just about preventing harm, right? It's also about making sure that Titans are used to actually benefit, like all of humanity.
Yeah, exactly. It's got to be equitable. We don't want to end up in a world where only a few people have access to these super powerful tools.
Exactly. It's about democratizing AI and making sure that the benefits are actually shared widely. And that means investing in education and training, so everyone has the chance to learn and actually use these technologies.
I'm also curious about, the impact on jobs. Like, as AI gets more advanced, there's this fear that it'll replace human workers.
I understand that concern, and it's
Yeah.
something we definitely need to address. But honestly, I think AI, including Titans, will actually create more opportunities in the long run. It's not about replacement, it's about augmentation.
So instead of being afraid of AI, we should be looking at it as this, like, powerful tool that can help us, be better at what we do.
Exactly. Titans can take care of those repetitive tasks, the boring stuff, and that frees us up to focus on things that really need human creativity and critical thinking, and of course, human connection.
Imagine a world where doctors can spend more time with patients, or teachers can really tailor education for each student, and, like, scientists are free to focus on those groundbreaking discoveries.
That's the kind of future I believe AI can help us build. It's all about empowering humans to, like, really excel at what we do best while AI handles the heavy lifting.
This has been an incredible deep dive. I mean, I've learned so much about Titans and the amazing and maybe a little scary future that they represent.
It's been a pleasure exploring this with you. AI is constantly evolving, and it's such an exciting field to be a part of.
It really is. And to everyone listening, thanks for joining us on this deep dive into the world of Titans. We hope you've gotten a better sense of just how powerful AI can be. And until next time, keep exploring and keep asking those big questions.